An arithmetic progression is a sequence where the difference between successive terms is constant. Now, the key thing to notice here is the difference between successive terms is constant. Now, as an example, let's use the sequence that we had seen before, which is the sequence of odd numbers. If you would notice, the difference between the second term here and the first term here is 2. So you have to add 2 to get to the second term here. Now, what about the difference between our third term and our second term here? It's also 2. What about the difference between here? This is also 2. And so it is for all the terms in our sequence. So don't forget, for an arithmetic progression, the difference between successive terms has to be constant. If we have a sequence where the difference between the successive terms are not constant, like for the Fibonacci sequence, that is not an arithmetic progression. For a sequence or a progression to be considered an arithmetic progression, the difference between each of the terms has to be constant. So in essence, what we're saying is when we have un plus 1 minus un, so we have a term minus the term preceding that term, we're supposed to have a common difference called d. In this case, our d is equal to 2. That is our common difference. Now, let's use this knowledge to write a generic formula for our arithmetic progression. Let me move this a little bit downward here. So if we have 1 here to be the first term of our sequence, and we represent our first term as A is our first term, and D is our common difference. Now, we know that our sequence here is simply 1. But what if we move to our second term here? To get our second term here, we would have to add our first term, which is 1, plus 2, which is the common difference that we have here. So algebraically speaking, this is going to be A, which is our first term, plus D, which is the common difference. Now, what about the third term here? We would have to add our first term, 1, plus the first common difference that takes us to the second term here, which is this 2, plus the second common difference that takes us to the third term here, which is the second 2 here. So here we can say this is A plus D plus D, or we can simply say this is equal to A plus 2D. Now, what about our fourth term here? You know the drift by now. We had our first term plus 1, 2, 3 common differences. So this is going to be A plus 2 plus 2 plus 2. And this is the same as saying A plus 3D. Now, you would notice that there's a common trend forming here. So now you know that when we continue, this is going to be the same all over. So we'll have that for the next one, we'll have A plus 4D. And for the sixth term, we have A plus 5D. Now let's use our fourth term here to write a general formula for an arithmetic progression. So if we have U4, which in this case is going to be 7, we know that the formula is A plus 3D. A plus 3D. So which means that here, when you're looking for the nth term of an arithmetic progression, we're going to add the first term of the progression to. Now we have U4 here, which is the fourth term, but we're only adding 3 Ds. So we're going to be having n minus 1 D. So this right here is a general formula for finding any term in an arithmetic progression, as long as we know A, which is the first term of that progression, and we know D, which is the common difference of the arithmetic progression. So don't forget, as un, which is the nth term of the progression we're looking for, equals A plus n minus 1D. So now, knowing this, let's solve some examples. So our first example says, if the first 3 terms of an arithmetic progression is 3, 7, and 11, what is the nth term of the arithmetic progression? Now, we've been told that this is an arithmetic progression, so we don't need to confirm that it is an arithmetic progression. But if we were not told and we want to confirm it's an arithmetic progression, all we have to do is find if the difference between each of these successive terms are the same. So we can say 7 minus 3 equals 4, which is this term minus this term, and 11 minus 7. 11 minus 7 is also equal to 4. So here we know that the difference between successive terms are the same. So obviously this is an arithmetic progression. Now don't forget our formula for finding any term in an arithmetic progression. That is un is equal to a plus n minus 1d. So our un here, our n here, we're looking for the nth term. So n here is equal to 10. A is the first term of our progression, and the first term, as we have been told here, because this is the first three terms, so the first term here is equal to 3. So A equals 3. And D, the common difference, is what we've calculated here. Our D is equal to 4. So we can go ahead and solve. So the 10th term is U10 is equal to our A, which is 3, plus n minus 1, 10 minus 1, and our multiplied by D, which is equal to 4. So U10 is equal to 3 plus 9 multiplied by 4. Here we have that 3 plus 9 multiplied by 4 is equal to 36, and 3 plus 36 is equal to 39. So our 10th term is equal to 39. For the next example, we're given this sequence 1 over 15, 1 over 12, 1 over 10, and we're told to find the 11th term of this sequence. So the first thing we need to do is, don't forget our formula is un equals a plus n minus 1d. So the first thing we need to do is find each of the terms on this. So we have that our n is equal to, we're finding the 11th term, so our n is equal to 11. Now our a, which is our first term, is equal to 1 over 15, as we have it here. And now our d. Now our d is simply gotten by subtracting any successive terms. So if we have 1 over 12, which is the second term, minus 1 over 15. Here we have an LCM of 60. So 60 divided by 12 is equal to 5. 5 times 1 is equal to 5. And 60 divided by 15 is equal to 4. So 4 times 1 is equal to 4. So we have 1 over 60, which means that our d is equal to 1 over 60. So now that we have all the terms, we can go ahead and solve. So U11, which is our 11th term, is a 1 over 15 plus n, which is 11 minus 1, multiplied by d, which is 1 over 60. And this is equal to 1 over 15 plus 11 minus 1 is 10 multiplied by 1 over 60. So 10 cancels out 60 to give us 6. So we're left with 1 over 15 plus 1 over 6. Here we can have an LCM of 30. 30 divided by 15 is equal to 2. 2 times 1 is 2. 30 divided by 6 is 5. 5 times 1 is 5. So we have 2 plus 5. And this is equal to 7 over 30. So our 11th term, U11, is equal to 7 over 30, which is our final answer. So our third example says, given that 2x, 5, and 6 minus x are the first three terms of an arithmetic progression, what is the common difference? So we have our sequence as 2x, 5, and 6 minus x. Now those are the first three terms. Now we want to get a common difference. Now don't forget that for an arithmetic progression, we have a common difference, which means that the difference between successive terms has to be equal. So it means that if we have here u2 minus u1, which is the second term minus the first term, has to be equal to when we have u3, which is the third term, minus u2, the second term. So what we're saying here is u2, which is our second term, 5, minus our first term here, which is 2x, is equal to our third term here, which is 6 minus x, minus our second term here, 5. So we can tell that this is 5 minus 2x is equal to 6 minus 5 here will be equal to 1 minus x. So now we can collect like terms by bringing x to the left-hand side and our constants to the right side. We have that minus 2x. If we bring minus x over here, it becomes plus x equals 1. And if we bring 5 over here, it becomes minus 5. So minus 2x plus x is equal to minus x. And 1 minus 5 equals minus 4. But this minus cancel out this minus, so we have that our x is equal to 4. So if our x is equal to 4, which means that our first term here, which is u1, is equal to 2x, and this is equal to 2 multiplied by 4. This is equal to 8. We have that our second term u2 is equal to 5, that's a constant. And we have that our u3 is equal to 6 minus x, which is 6 minus 4. This is equal to 2. So numerically, our sequence is actually, the first term is equal to 8. So this is 8, 5, and 6 minus x is equal to 2. So our common difference in this case, d, don't forget that d is equal to u2 minus u1. So u2 here is equal to 5, and u1 is equal to 8. So this is minus 3. So our common difference is minus 3. Now let's move on to arithmetic series. Now don't forget that we had said that a series is simply the addition of the terms of a sequence. So if we have a sequence of numbers 1, 2, 3, up until 7. Now to find the series of this number, of this sequence, is simply we have 1 plus 2 plus 3 plus 4 up until plus 7. And this is simply 28. But what if we had a longer sequence, such as this 1, 2, 3, up until 98, 99, 100? Now, what if our sequence had 100 terms in it? We would not be able to efficiently add up all these numbers quickly and without making an error. There has to be a way to be able to calculate this arithmetic series without going through that long process of adding everything together. Now, let's assume that this is our sequence 1. This is our sequence 1. Now, if we had a second sequence, S2, which is the same 100 digits, but this time we're bringing it from 100 down to 1. So we have 3, 2, and 1. So here, the first term is 1 and the last term is 100. But for S2, the first term is 100 and the last term is 1. So they are basically the same thing. We just inverted it. Now, if we add both sequences together, we have that S1 plus S2 is equal to, so that's going to be 1 plus 100, which is 1 plus 100 here. And then we have 2 plus 99, 2 plus 99. And then we have 3 plus 98. And we'll do that up until we have 98 plus 3 here, 99 plus 2, and finally we have 100 plus 1. So essentially we're going to be having 101 because 1 plus 100 is 101, 2 plus 99 is 101. So essentially we're going to have 101, 101, 101. So we're going to have 100, 101. So we're going to have S1 plus S2 is simply equal to 101 in 100 places. But don't forget that these two S's are the same. So S1 plus S2 is simply equal to 2S. And this is equal to 101 times 100. So essentially what we're saying is that for S, we have that 101 times 100 divided by 2. And so this is equal to 10100 divided by 2. So the series of this sequence is going to be equal to 5050. Now that's a shortcut that works. But let's turn this shortcut into a formula term that we can use for any sequence we have, regardless of the common difference between them. Let's do this in an algebraic way. So let's write our sequence 1 and our sequence 2. So for our sequence 1, we know that A is the first term of the sequence. And we know that the second term is A plus D, and the third term is A plus 2D. So now let's write the last three terms of the sequence. This is going to be A plus N minus 3D, A plus N minus 2D. And we know that UN is A plus N minus 1D. We've discussed that before. Now for the second sequence, we're starting from the bottom here. So the first term here is going to be A plus N minus 1D, A plus N minus 2D, A plus N minus 3D. And the last three terms are going to be A plus 2D, A plus D, and A. Now let's do this. Let's do what we did before, which is adding these two sequences together. So here we have that this is going to be equal to A plus A is going to give us 2A plus N minus 1D. So here we also have A plus A, which is also equal to 2A. Now let's have a sidebar here. We have D plus N minus 2D. So D plus N minus 2D. So D is common to both terms here. If we factorize that, we have that D is equal to D divided by D is 1 plus N minus 2. because n minus 2d divided by d will leave us with n minus 2. So minus 2 cancels out 1 here to leave us with n minus 1. So essentially we have the same thing here, which is n minus 1d. So I can get rid of this. So essentially what I'm saying is that we're going to have the same term, just like we had 101 for each of those terms before. We're going to have the same term for every one of these additions that we go through, which is 2a plus n minus 1d. So now if we add up all of these n's, we'll have that we have 2a plus n minus 1d. And we're going to have that n number of times. N number of times is the number of times that we have in these sequences. Now don't forget that this is s1 plus s2, so this is going to be 2s is equal to this. And what we're saying here is that s is equal to n 2a plus n minus 1d all divided by 2. So essentially we're writing a new formula here. So this new formula is going to be s is equal to n over 2 2a plus n minus 1d. And this is the formula for finding the sequence of any arithmetic progression that we have. But we're not going to stop here. We'll find that s here, we can tell that this is the same as saying s is equal to n over 2, and then 2a is a plus a, which is simply 2a, plus n minus 1d. But don't forget that we have that a plus n minus 1d right here. Don't forget that this is un from what we have looked at before. So this is the final term of our arithmetic progression. So we can replace this here by the final term. So we can say that s is equal to n minus 2 into a plus l, where l is the final term of our arithmetic progression. So we have two formulas. So the second one is n over 2 a plus l. Now we use this when we do not know the last term of our equation. We only know the first term and we know the common difference. And we use the second formula here when we know the first and the last term of our arithmetic progression. So now that we have these two formulas, let's use them in solving some examples. So if we have a sequence which is an arithmetic progression which has a lot of terms in it and we want to find the series for that arithmetic progression, we have two formulas that we can use. The first one is Sn is equal to n over 2 multiplied by 2a plus n minus 1 multiplied by d, where a is the first term, d is the common difference, and n is the number of terms in the arithmetic progression. But we also have a second formula, which is Sn is equal to n over 2 multiplied by a plus l, where l here is the last term in our arithmetic progression. So we use our first equation here when we only know the first term and the common difference, and we use our second formula here when we know the first term and the last term of our sequence. So now that we know these formulas, let's solve some examples involving them. So our question says, if the first three terms of an AP is 8, 5, and 2, what is the 16th term and the sum of the first 16 terms? So our sequence is 8, 5, and 2. So here, let's see the terms that we know. We know our first term, a, is equal to 8, and we know that our common difference is 5 minus 8, which is equal to minus 3, which is the second term minus the first term. So d equals minus 3. Now, we know that n is 16 because we have been requested to find the 16th term. Now, let's remind ourselves of our formulas. To find the nth term of an arithmetic progression, un, That is equal to a plus n minus 1d. And to find the series of an arithmetic progression, if we do not know the last term, we have this is equal to n divided by 2 into 2a plus n minus 1d. So the first part of the question says, what is the 16th term? So the 16th term is u16 is equal to a, which is 8, plus n, which is 16 minus 1, multiplied by d, which is minus 3. So here we have that u16 is equal to 8 plus 16 minus 1 is 15, multiplied by minus 3. So u16 is equal to 8 minus 45, which is equal to minus 37. So the 16th term is equal to minus 37. So to find the sum of the first 16 terms, which is S16, that's equal to n over 2 multiplied by 2a plus n minus 1d. So we have this is 16, n is 16 divided by 2, 2 multiplied by a, which is 8, plus n, which is 16 again, minus 1, multiplied by our d, which is minus 3. So here we have that 16 divided by 2 is equal to 8. 2 multiplied by 8 is equal to 16, plus 16 minus 5. 16 minus 1 is equal to 15, multiplied by minus 3. So here we have that 8 multiplied by 16 minus 45. And that is 8 multiplied by 16 minus 45 is equal to minus 29, is equal to minus 232. Now we can also use our second formula, which is n over 2a plus l. Because don't forget that just before we calculated the sum of the first 16 terms, we found out the 16th term, which is minus 37. So let's just try it out to see if we get the same thing. We know that the last term now, we've calculated it as minus 37. So we have that S16 is equal to n over 2 multiplied by a plus l, right? So n is 16 divided by 2, and our first term is 8 plus our last term, which is minus 37. So we have that 16 divided by 2 is 8, and 8 minus 37, this becomes 8 minus 37. So 8 minus 37 is equal to minus 29, as we have here. And this is also equal to 232. So you can use either of these two formulas to find the series of an arithmetic progression. It just depends on which term you have. If you have the final term, then you use this. If not, you use this. So let's go on to the second example. So our second example says, for the arithmetic progression 2, 5, 8 up until term n, find the series of the first 20 elements. So we have that Sn is equal to n over 2 into 2a plus n minus 1d. So our first term here, a, is equal to 2. We have that our n is equal to 20, and our d is equal to, and our d here is 5 minus 2, which is 3. So our d here is 3. So let's go ahead. So S20 is equal to 20 over 2, 2 multiplied by a, which is 2, plus n, which is 20 minus 1, multiplied by our d, which is 3. So we have that S20 is equal to 20 divided by 2 is 10, 2 multiplied by 2 is 4, plus 20 minus 1 is 19, 19 multiplied by 3. So we have that our S20 is equal to 10 multiplied by 4 plus 57 is equal to 10 multiplied by 61. So our S20 is 10 multiplied by 61, which is 610. And that's our answer. Our next question says, if the sum of the first 14 terms of an AP is 1050 and its first term is 10, find the 20th term. So don't forget that Sn is equal to n over 2 into 2a plus n minus 1d. I keep rewriting this so that you can get it into your head and it becomes a usual thing. So here we have that our n First, let's deal with the first 14 terms. So n here is going to be 14. And our a, we've been told that the first term is equal to 10. So our a here is equal to 10. And we know that the sum of the first 14 terms, S14, is equal to 1050. So here, first, let's find our common difference. So if we write our formula, we'll have that S14 is equal to 14 divided by 2 into 2 multiplied by a, which is 10, plus 14 minus 1 multiplied by d. And we know that S14 here, we've been told that that is equal to 1050. So now we have to make d the surrogate of the formula here. So we have that 14 divided by 2 is 7, 2 multiplied by 10 is 20, plus 14 minus 1 is 13, d equals 1050. So this is equal to 7 times 20 is 140. If we expand this, and we have that 7 multiplied by 13 is equal to 91, d equals 1050. So if we make d the surrogate for formula here, and we move 140 to this side, we have that 91d is equal to 1050 minus 140. And this is equal to 910. So if 91d is equal to 910, if we divide both sides by 91, we have that d is equal to 10. So now we have our common difference d. But that's not what we're requested to find. We're requested to find the 20th term. So the d is just to help us find the 20th term, because our 20th term, u20, is equal to, don't forget, this is a plus n minus 1d, which is 10 in this case, plus our 20th term, 20 minus 1, and our d is 10. So this is 10 plus 20 minus 1 is 19, so 19 multiplied by 10. And this is equal to 10 plus 190. So our 20th term is equal to 200. So our last question says, how many terms of an arithmetic progression given by 24, 21, 18, and so on must be taken so that the sum Sn is equal to 78? So our arithmetic progression is given by 24, 21, 18, continuing. Now, we know that our first term here, a, is 24. So our common difference, d, is 21 minus 24 is minus 3. 18 minus 21 is minus 3. So our common difference is minus 3. And now what we're looking for is n. We're looking for the number of terms whose sum would give us 78. And we know that our Sn is giving us 78. So we know that for an arithmetic progression, the sum of the series Sn is given by n divided by 2 into 2a plus n minus 1d. Now let's substitute the values that we have into this formula, and then we solve for n. So this is going to become, our Sn is 78 equals n, we don't know n divided by 2, 2 multiplied by a is 24, plus n minus 1, and our d is minus 3. So now we solve for n. Now this becomes 78 equals n over 2. 2 multiplied by 24 is 48, plus, here we have that n multiplied by minus 3 is equal to minus 3n. So I'll change this to minus 3n, and minus 1 multiplied by minus 3 becomes plus 3. So now we can combine these two constants here to give us 48 plus 3, that's 51. So our equation then becomes 78 equals n over 2 into 51 minus 3n. So now we can expand this and then solve for n. So if we cross multiply, we can take 2 over to this side. So we have that 2 multiplied by 78 is equal to 156 equals n into 51 minus 3n. I'm trying to go through everything step by step so that we don't get it confused. And now we have that 156, if we expand this bracket, is equal to n multiplied by 51 is 51n, and n multiplied by minus 3n is equal to minus 3n squared. Now we can move all the terms to one side of our equation to form a quadratic equation. So that would give us that if we move minus 3n squared to this side, we have plus 3n squared. And if we move 51n to the other side, we have minus 51n. We still have our plus 156, and this is equal to 0. Now you recognize that this is a quadratic equation, and we can solve this quadratic equation to give two values of our n. So now if we divide through this equation by 3 to simplify the equation and deal with simpler numbers, we would have that 3 cancels out 3 here, and we have n squared minus 51 divided by 3 would give us 17. So we have 17n here, and 156 divided by 3 would give us 52. So this is our new quadratic equation, and then we can solve. And as you already know, to solve quadratic equations, we're looking for the factors. We're looking for 2 factors of a constant here, 52, which when we multiply it would give us 52. But when we add or subtract, will give us 17. Here we can use 4 and 13. So 4 times 13 is equal to 52. But when we have minus 4 minus 13, this is equal to minus 17. So we can substitute minus 17n here for minus 4n minus 17n. So now we have that our quadratic equation is n squared minus 4n minus 13n plus 52 equals 0. So now we can factorize this equation. For these first 2 here, we have that n is common to both terms here. So we have n outside the bracket. N squared divided by n equals n. Minus 4n divided by n equals minus 4. And for the next 2 terms, we have that minus 13 is common to both terms. So minus 13n divided by minus 13 equals n. And 52 divided by minus 13 equals minus 4 equals 0. So from here, we can write out the common terms to both sides, which is n minus 4. And then we write out the terms outside. So this is n minus 13 equals 0. So from here, we know that anything multiplied by 0 is equal to 0. So either n minus 4 is equal to 0 or n minus 13 is equal to 0. And here we can tell that n is equal to 4 or n is equal to 13. So in other words, we must have 4 terms of n, 4 terms of this progression for us to have 78 as the sum, or we will have 13 terms. And if you've not figured it out by now, the reason why we have 2 numbers that can lead up to 78 is because the common difference here is a negative number. So for example, here, if we have the next term is going to be 18 minus 3, that will be 15. If you add up these 4 terms, you would have 78. But if you continue, this is going to decrease until you get to a point where you have minus as well. And if you have 13 terms, if you actually write down the terms of this arithmetic progression to the 13th term and you add it all up, you would also notice that you will get 78. So that's how we solve these questions. Now we've come to the end of our arithmetic progression. But before we finish, let us summarize everything that we've learned so far. Now, by way of summary, we've learned so far that for a set of numbers to be considered a sequence, the numbers have to be written in a particular order. It doesn't matter if the order is increasing or decreasing, but there has to be an order for a set of numbers to be considered a sequence. Now, we also learned that to find the series of a sequence, all you have to do is to add up the terms of that sequence. Also, we've learned that for a sequence to be considered an arithmetic progression, the difference between successive terms must be constant. That means we need to have a common difference for it to be considered an arithmetic progression. We've also learned that to find the nth term of an arithmetic progression, the formula is a plus n minus 1 multiplied by d, where a is the first term, n is the number of terms that we're looking for, and d is the common difference. We've also learned that to find the sum of an arithmetic progression or the series of an arithmetic progression, we have 2 formulas. The first one here is used when you do not know the last term of the arithmetic progression, and the second one on the right here is used when you know both the first and the last term of the arithmetic progression. In the next video, we're going to be talking about geometric progressions. I'll see you.